Yeah, I
Okay.
can. Yeah, I'm recording it. Don't worry.
Okay, perfect. Thanks, Maria. So, yeah, good morning, everyone. This is the last day. I just want to show that, the videos were added from day 2 and day 3 as well, and slides for today can be found here. I've added a couple more resources as well, but we can go straight into the presentation. Again, like the 2 previous days, we're going to start with the quick survey again, and we have less people, so this should be pretty fast. I'll put on the chat the code, and this is just to see, after the demos we did yesterday, and it's just one question, how you guys are feeling. So we should have just about like 5 people answering. Okay, we had 1 person, 3, I think there's only 1 person missing. Let's give a couple more seconds. But it seems like although we have less people, okay, we got all of them. It seems like, the higher level concepts are probably being understood better. Neural networks is still kind of in the middle, which is fine. It's very complicated, and we only did like theory. We didn't do really the practical part, so that's okay. Let me go back to the presentation, and let me make this full screen. So today we'll be just understanding about the basic environment workflow for the classification for our crop mapping. So we're going to talk about Google Earth Engine, Tensorflow, Google Colab, Google Cloud Platform, storage, and AI. So we are not going to do any coding for now, though we can try to play a little bit at the end. But it's just for you all to understand how, where we create the data, where we store the data, where we run the model, how is the workflow, right, to build a model and host that model somewhere so we can have our crop map at the end. So it's going to be very high level workflow of the environment. So this is what it looks like. This is the general workflow. Everything is Google based. We use Google, and how it is we have Google Earth Engine, which we're going to talk about each of these separately. But Google Earth Engine is where we're going to have our training data stored at the beginning. And then, this training data would be, our polygons, our crop data, right? Our reference crop types. That's going to go into Google Cloud Storage because we need it to be in the cloud. Then for the model, we need to go, we need to use TensorFlow and Colab together so we can train our neural networks, our model. This cannot be done in Google Earth Engine, and that's why we need to export this training data to a cloud storage and then build the model in this other environment here, the TensorFlow and Colab. And again, we're going to talk about this. And once the model is like trained and we're happy with the model, then we can export this model to be used in Google Earth Engine or even in other places as well. It's very versatile. But this is the basic idea. We can have, the model exported to Google Earth Engine and have our map there as well. So this is the very high level overview of the workflow. And we'll be seeing this this diagram through the steps as we go through them today. So another way of showing this is we're doing this, right? We have our satellite imagery. We have the different bands here, even some indices, and if we use them, we are sampling some points here, which here it has a cropland class, forest water, but for us it would be the crop types, right? It could be broadleaf tree crop, shrubland, anything, right? What we are interested in, and we sample that, right, at the satellite imagery. Then we have our training data, which is a table, right? We have each feature here. It could be a polygon or a point, and we have the information for each band, right? Then we use this training data to train our neural network, and we do the inference, right? Which we talked about inference. That's the classification. That's like running the model so we can get our final output, which would be the crop type map, right? Which each pixel is classified as a crop or a class. And this is also just showing Earth Engine. That's where we get our imagery, our training data. We have to export this as Tensorflow records. We're going to talk about what Tensorflow records are, but that's in the cloud storage, that's in Google Cloud. And then we use Python, and that's where the Tensorflow and the Google Colab are to build our model. After we built our model, we can host that model in the Google Cloud, and then we can use that model back in Google Earth Engine to do our classification and get our final map. So the goal of today is like understanding how this works, because from like in a short time from now, like when we test more the model, we get something that we like, and we share that with you. You understand what's happening, which tools you need to use if you want to change something. So we start with Google Earth Engine. I'm not sure if I would assume some of you have used it before, or maybe not. Have any of you used Google Earth Engine before? Yes, okay, yeah.
Yes.
Okay, so most of you, right? So yeah, I don't need to explain very in depth, but Google Earth Engine is this, they call planetary scale platform for Earth science and data analysis. It's a huge deal for, the geospatial analysis, because it contains a multi-petabyte catalog of satellite imagery and geospatial data sets. So like every satellite imagery you can think of, like Landsat, Sentinel, all, climate data, everything is already stored, and it's stored in Google's like server. So we don't need to download anything, right? Everything is in Google's cloud. So it makes it very easy for us to just use this platform. They have an API available in JavaScript, which is the web browser version, and then Python, where it's the Google Colab version. And you can use Google Cloud to do your own geospatial analysis, also your own data you can use. You can upload data sets to Google Earth Engine. And then it's available for academic, nonprofit, business, and government users for no cost, right? So it's very, very awesome that Google put this platform together. So again, this is just to highlight, contains more than 40 years of historical imagery. There's, talking about Landsat, and then, other scientific data sets. They are updated and expanded daily. There's a link here where, you can see all the data sets that they have. It's a lot, but just some of them here. Copernicus, global land cover layers. They have Sentinel-1, so the SAR, C-band data. They have Sentinel-2 as well, and Sentinel-2 cloud probability. These are just some of the data sets. They have a bunch more. This is what it looks like. So you guys have used this, so you know how it looks like. I added here a link at the bottom if if someone hasn't signed up yet. If you guys want, we maybe can do a demo later, but you can sign up. But this is what it looks like. You can see that there's a map here, and you do your programming here in the middle. And it's very easy because, as I said, everything, all the data sets are in the cloud, right? So it's very easy just to use the search bar, and you can find, different rasters, different vector data to find. So this is, yeah, just showing the structure of Google Earth Engine. Again, you can draw on the map, so you can create your own vector data, your own polygons straight in Google Earth Engine. You have your scripts here on the left side. You have the documentation where you find information about all the function and everything. Assets, that's your data, where you can upload some data sets from your local machine. Search bar, we already mentioned. You have here the part where you have your code, right? And they use a Google Earth Engine specific JavaScript for that. Data inspector, that's where you click anywhere in the map and it's gonna give the information about that specific pixel. Output console, that's where you get that's the output from your code, right? If you print something, if you do something, it's gonna show on the console. Batch task, that's where you're exporting something, either to, you can export to the Google Cloud, as we're going to talk about. You can export to your Google Drive as well, and export as an asset to keep in Google Earth Engine as well. So all you need, like the magic of this is, all you need is internet connection, right? And then you can use this from your browser. And you can run some machine learning algorithms here, such as the card classification, which is that unsupervised classification type we talked about. You can run random forest, support vector machines, k-means, but not neural networks. That would be too much for the platform, and that's why we have to go to Google Colab and TensorFlow, and that's what we're going to talk about. So another, yeah, again, just hitting this because it's awesome. They do on the fly computation, so you can, everything happens there at the click of a button, and batch computation. So that means that when you run a script, that processing is separate, it goes separately, parallel in different computers in Google's server. So it's not happening everything in just one. It's happening in parallel, which makes it very, very fast. And this is just to show the data that you guys collected. Those are the polygons over Rodenak Pondal. That's already stored in Earth Engine. And again, this is here, but we're gonna also use this in Google Colab because we cannot host build neural networks, machine learning models here. So after you have the data, for example, those polygons that I just showed, that data gets exported to the Google storage, right? So that we can use the Google's AI platform using Google Colab and then TensorFlow to build and train your model. So that's what we're going to talk next, Google Cloud. So it's very simple, just the suite of cloud computing services that runs on the same infrastructure that Google uses internally for its end users. So everything like Google Search, everything, it's the same. Everything runs in Google Cloud. They have this Vertex AI, that's where you build, deploy, and scale machine learning models, and the cloud storage where you store your data, right? Instead of storing locally, you're going to store it in the Google Cloud. So this is what it looks like. This is the Google Cloud platform. You have different projects, and then you have storages. So here, for example, I have like one bucket, and we talked about because we're using the cloud, it bills you if you use a lot of it, but we talked about that. We do have, Servier has a lot of resources for this. And this is what a bucket looks like. As I mentioned, we're going to talk about TensorFlow record, but you can see here that these two files are TensorFlow records files, and this was exported from Google Earth Engine, and this is going to go to Google Colab and TensorFlow. So now that we have the data in Google Storage, the cloud platform, we're going to go into the Colab and TensorFlow to build our model. So what is Colab, right? It's actually called Collaboratory, but Colab is for short, and it allows you to write and execute Python in your browser. So Google Earth Engine is JavaScript, but Google Colab is Python. You don't need any configuration required to use it. Again, it's also just a web browser. It's like Google Earth Engine, so you don't need to download or install anything. It's based on Jupyter notebooks. I'm sure you guys have heard of, or even you use Jupyter notebooks. You can get free access to GPUs. And GPUs are this is important because those are the graphics processing unit. And for machine learning, for like image recognition, like we are trying to do with satellite imagery and the crop data, GPUs are being used, I guess, more than CPUs, because they can do more tasks faster than just regular CPUs. It's also very easy to share, just like Google Earth Engine. You can share your script with your colleagues very easily. And then, yeah, your scripts and notebooks are stored in your Google Drive. So this is what it looks like. We can also maybe do something at the end if you guys want. But it looks like this. And the good thing about Google Colab is you can use Markdown together with code blocks. Markdown is just a language to write just regular text. So it's really helpful because it's easy to understand what's going on instead of just having lines of codes and comments. But this is what it looks like. You have table of contents, you have your files here that you can access, and all of that, and everything gets saved into your Google Drive. And obviously we can run TensorFlow here to build our models. So yeah, again, from the Google Cloud Platform, the storage, you import those TensorFlow records into the Colab environment. Then you can prepare the data in the right format. You can build a model, validate your model. You save that model in a cloud bucket, so it goes back to the Google Cloud Platform, the storage. You make the model Earth Engine readable so that we can open that model in Google Earth Engine, and then you push that model to there. So I guess the point here is that because this happens, you make the model Earth Engine readable, and you push that to the AI platform. There's the option to reuse that model, right? You can share that model with people and apply that to other regions or other situations. So it's really advantageous to use this. Okay, so now that we are in Colab, we have imported the training data, everything that we need. We can use TensorFlow. So TensorFlow is an end-to-end open source machine learning platform. It is the core open source library to develop and train machine learning models. And it has comprehensive, flexible ecosystem of tools, libraries, community resources. A lot of people are using this. Many, of the big companies are using TensorFlow with their machine learning research and tools. And you can easily develop and deploy machine learning applications. It contains a rich collection of tools for building models, and that includes data processing, ingestion, model evaluation, visualization, and survey. And yeah, as I said, you not only train, but you can deploy your model in a variety of devices. So you can have your model like running in the cell phone as well. You can have a front end for your model where people can access through their cell phone. So it's really a good thing to use. This is just a page I added here. This is actually a tutorial. So TensorFlow is very good because they do have a lot of tutorials and like resources, so people can learn how to use and apply to their own situation. And if we want, we can do some of this in the end. But I left here a link for one of the classification tutorials they have. And in TensorFlow, that's what we can do, right? We can build our model, and that's what we want to do. We can have those fully connected convolution neural networks that have all those layers. We can do the inference and have our segmented image at the end. So now, okay, so yeah, we have Google Earth Engine, right? The first step, we export that as a TensorFlow record. So what is a TensorFlow record? So the difference that because of the like high computational requirements to build train a model, a TensorFlow record is just a different format for your table and image data. It's a binary format, so it just makes the data like smaller, but keeping the same information. That's pretty much what TensorFlow record is. It just turns your data into a binary format, so it's lighter to be used to build and train the model. So you export that, the samples and the image as well, the satellite imagery. You use TensorFlow to build and build your model, and then you're going to predict. Those predictions are also saved in TensorFlow record. And then, as I said, you can upload that back to Google Earth Engine, so you can access through Google Earth Engine. And that's all done in Google Cloud, as we've seen. These are just different workflows to show the same thing, pretty much. And then, so that in the end we can have a final product. This is just an example. This is actually Severe Mekong's, the regional land cover measurement system, the RLCMS, and over Cambodia. So we do right in the end have something like this with the different crop types here instead of the land cover. So this is what I have for today. We can do maybe if you guys want like work on Google Colab, or we can talk about the next steps. I don't know what's your preference. Today, yeah, it is a little bit shorter. It's just a really like overview for you guys to know, where everything is happening, where you need to go, which tool to use, but without like actually going to the programming at the moment. So have you guys used Google Colab before? Because maybe we can go through that link, the example here. Oops.
I think it would be good to go through Google Colab, because I think it would be new for most of the team. And they're very familiar with the Google Earth Engine, but I don't, yeah, I see, no, yeah. So please, maybe, yeah, Google Colab, yeah. And maybe, yeah, spend some time with that.
So, okay. Yeah, this is I don't know if you guys prefer working on your own, or should we do this together? Because I can open here and we can do it together, or I can just paste here, you guys spend some time, then we can come back and go through it together. Any preference?
Why don't you first show, like, go together, and then maybe people can work on their own?
Yeah.
Okay.
Yeah, so if you have a Google account, like a Google Drive, you should be able to access this. So in order to, let me just open this without this. This is what, the website is collab.research.google.com. This should open like just a blank page, and you should have, a recent tab where you can pull some of the notebooks. Your notebooks would be here. They also have some examples here that, for beginners, it's really useful. Also shows your Google Drive. If you have something in the Google Drive, I do have a couple of notebooks in my Google Drive. This is actually the model of the crop mapping that was built by Nishanta. And then you can also open straight from GitHub. If you have GitHub connected, you can upload any notebook file as well. Let me cancel then. And yeah, once you open like Google Colab, the screen, the background, it just tells you what it is. So it's just a notebook, so you can go through. And as I said, you can, each of these are cell blocks. You can see that in between, you can add code or you can add text. As I said, you can use, it's different from Google Earth Engine because you have these text blocks, right? Right now, this is like me editing a text block, and what they use here is Markdown language. Let me, okay, yeah. And the actually code blocks, they are these ones, and it's Python, right? So here it's similar to Google Earth Engine, but instead of using a var at the beginning, you just name your variable, and here it's assigning 24 times 60 times 60, which is like seconds in a day. And you run each cell like this, and then you have your output. It's running. Shouldn't take this long. But yeah, and then you get your output, and it's just programming, right? Here's getting seconds a week, which is 7 times the seconds, your variable seconds in a day. So that's it. And then it's because it's Python, you can import all the libraries, the main important like Python libraries. Here in this case, it's NumPy, Matplotlib. You can have your charts here, your plots inside Google Colab. And machine learning, it introduces to machine learning. Here is not going to have any code, but it's a lot of useful resources for machine learning. Another good thing is you can actually export the Google Earth Engine package. So you can export that into Google Colab. So then you can have like a map inside Google Colab as well. Does that make sense? So maybe let me post this in the chat, and then you guys can open that. And here are the files. These are the files that you have in your Google Drive. That's what these files are showing. And Google Cloud as well, both of them. So it's pretty much a notebook. For those who have used like Jupyter notebooks, it's exactly the same. And this example that I shared, this is actually doing classification. It's actually using machine learning in TensorFlow. And it's using, I think I mentioned this MNIST like data set, but it was like handwritten numbers. This one is actually clothing. They have clothing pictures, and they are trying to predict that using TensorFlow. So this is a good example. Like we can go through this or together, or if you guys want to go through it, and then we can talk about it. But you see here ReLU, right? This is the activation function we talked about, and it's going to have those terms that we learned. So things are instead of, I think it's going to make more sense because we went through these concepts together. We have our training images, our test images. You're gonna see, these numbers are like the pixel size. We talked about flattening. We talked about, like pooling and that sort of stuff, convolution. So the data is being like processed. We talked about epochs, right? In this case here, they have 10 epochs. So the entire training data is going through the neural networks like 10 times to learn. So it's a lot of the terms we've used. So maybe if you guys wanna like try to go through this notebook, I think we can probably do that. How does that sound? Sounds good. Okay. Because yeah, this is like a real example. And the way, yeah, you can just let me see. Yeah, so that link that I pasted is gonna open this page that I was at. And then the way to go through the actual tutorial using Google Colab is you have to click here, Run in Google Colab. That will open a new notebook, a new Colab notebook, where you have, the steps needed to go through the exercise. Have you guys, so you guys used Google Earth Engine before, so do you guys also have experience with Python as well? Some of us, okay. Little bit, yeah. No, it new for me, yeah. That's okay. Yeah, it gets a little complicated, right? Because you used to Google Earth Engine and then you have to migrate to Google Colab, which is Python, and starts it makes a knot in the brain. I agree with that. And just, this is just one example. They're probably using a model that's already hosted, so we're not gonna go through like the complete workflow that I've just shown you guys, from Google Earth Engine to exporting SCF record in the Google Cloud Platform, using Google Colab, and then going back to Google Earth Engine. This is just everything here is just Google Colab. And I think they should have here in the end. Yeah, it predicts the straight here. It doesn't even export the model, but that's okay. Yeah, so another thing is it uses Keras. Keras is just, it's a high level, it's built on top of TensorFlow. Um, it's just a high level API to use TensorFlow. So you guys wanna try to run in your own, like add your own, and then we come back in a couple of minutes. Or maybe I can just give a quick overview. Yeah, so okay, let me just go.
So yes, I think so.
Yeah.
I think it's good if you can run it slowly and then everyone's follow it, because I'm sure that there are
Okay.
some people that are a little lost and don't know how to run it properly.
That sounds good. Yeah, so okay, we'll start. So yeah, as I said, this is trying to classify images of clothing. And right here, this first cell is just importing the TensorFlow library that we talked about. And so it's just import TensorFlow, and then it's importing as TF. That's just to make this name like smaller, so it's easy to use later, the package. And it's, importing other packages as well, as such as NumPy, which deals with, numbers, and also Matplotlib, which is for plotting data. It's for plotting graphs and charts and stuff like that. And then the sprint here is just to show which TensorFlow version we are using. And it shows here 2.5. I think it's the most recent. So the first step is to import the data set that we're going to use. So it contains 70,000 grayscale images in 10 different categories. So right, instead of like they have blouses and trousers and shoes and that kind of type of category. And yeah, the image is shown individual articles of clothing at low resolution. So each of these are 28 by 28 pixels. That's very low resolution. But it's good to, for our example here, because we don't want like big data right now. So here in this next cell block here, it's just getting the data set, it's assigning the fashion, the fashion data set. It's grabbing that from the TensorFlow Keras. So it's already located in the library, and we are just assigning a variable name to it. So it's basically grabbing all of this, those 70,000 different grayscale images, and putting to this fashion MNIST. And here it's just grabbing the training images and also assigning labels, so we can differentiate between training and test, and loading that. So you can see it's downloaded data, it's stored in the Google Cloud. So it's just getting those data sets, the train and the test images. And you can see like here just the numbers, how many they have. Yeah, so these are the different classes. We talked about 10 categories. So those are them, and each of them has a label, right? 0 is t-shirt, top, 1 is trouser, pullover, dress, and all of that. Each of them has a singular label. And again, those are 28 by 20 pixels or NumPy arrays. And then the pixel values ranging from 0 to 255. This is just the image brightness. So like a very bright, like a white pixel will have a value of 255, and then a black pixel will have a value of 0. Here is just assigning a list to the different classes that we have. It's similar to the Google Earth Engine list. It's just the strings of each class here, and we have 10. And then here it's just like exploring the data. So we're getting our trained images, and we're looking at the shape of it. And as we can see, we have 60,000 training image, and each of them are 28 by 28 pixels, as we've seen. And again, yeah, the same thing, right? Because we have 60,000 images, we have 60,000 labels, right? Because each image belongs to one of the 10 labels. And here just showing 0 to 9. This is the entire array. So these dots here, it's showing that they're, because we saw it's 60,000 images, it contains 60,000 different numbers here, each number representing the different label for each image. And for the test image, it's 10,000, right? We saw that we used most of our data for training the model, and then to test we have less than that, right? And it's just showing again 10,000 images, 28 by 28 pixels each image, and then 10,000 labels as well. So here, pre-processing the data. So before we go, does this make sense? Like our data set, what we're doing here, the classes. Before we go into the pre-processing, like, do you guys understand the data and the classes for each of those images?
Yeah, so should Andrea repeat again, or everybody is okay until now?
Okay. So to pre-process, this is plotting the train images. This is plotting the first train image. Train images is a variable that contains 60,000 images, and is grabbing the first one, right? Because it has the 0 here. And all of this PLT is that matplotlib package where it plots the data. So we can see the first one, it looks like a shoe, right? And as we said, it contains, it's from 0 to 255. That's the brightness of the pixel. So we can see like around the shoe, it's only black pixels, right? Because it's 0. And then the shoe itself, it contains the different brightness here, which are these values. So this is just like showing the first image of our training set. And what it's doing here, it's gonna scale these images to a range of 0 to 1. So it's kind of normalizing the data before feeding into the neural network model. So what it's doing is dividing by 255 so that we have only values from 0 to 1, not like 0 to 255. And it's doing that for both training images and the test images as well. So it's just normalizing the data, like the NDVI. And then to verify if the data is the correct format, they're going to display the first 25 images from the training set and display the class name below each image. So it should be all black and white because it's just 0 from 1. And then it's displaying like the class name as well. So yeah, it's ankle boot, t-shirt. So it looks right, because this is actual address, this is a t-shirt. This is just checking to see if the scaling happened, if this normalizing step happened, and if the labels also are correct, which they are. That's a good question. Why is it important to normalize? So in this case, well, in this case, we only have one type of data. But so I think for this case, so you have it's just less just for computational practices. So you have less data going to the model, so the model runs faster. But if you had different data sets that would have like different ranges, instead of 0 to 255, maybe you have 0 to, I don't know, 1028, then normalizing makes that data comparable, right? Apples to apples. This case, I think it's primarily for just computational resources. Okay, so building the neural networks requires configuring the layers of the model. So yeah, we talked about layer, right? And in this case, what's happening is we have our 28 by 28 images, right, with pixels, and that's setting the shape here, which the input shape of our image is 28 by 28. And then the first layer is a layer that contains 128 different neurons, right? We talked about the first hidden layer, and this one in this case have 128 different neurons. The second one has 10. So that's what we're defining here. Our flatten is just our input layer where we have our input data set, and we set the shape to 28 to 28 because that's what we talked about. Is it has 28 by 28 pixels each image, and you can see here that we are also setting the activation function for the first hidden layer, which is the ReLU. So this is one model with 2 hidden layers that we are setting here. Yeah, this has a reason to be set to 10 because we have 10 classes. This will be kind of like a score to indicate one of those 10 classes.
Yeah, maybe. Sorry to jump in. It's better to talk. But so I see maybe that's so the 128 nodes. So that can be 64, or they can be like any number,
Right.
or it has to be in bits, or why we define those numbers. Yeah, let's see. For the 10 is fine because we have the 10 classes. So that's for the last
Yeah.
layer. But yeah, for the other one, is there any rule that tell us how we should, or what is it like, more or less the correct number on that?
Right. Honestly, for this specific example, I'm not sure why they use 128, but yeah, usually it goes 64, 128, just 256. It goes that way, but I honestly do not know why they use 128 here. But we can also try like changing this later. And I apologize for that. I mentioned this as a tutorial, but I didn't plan actually to go through. But but yeah, I don't know for this. I think it's just experimental. Yeah, I haven't done this myself before. So now to compile the model, we talked about, right? We talked about loss function, optimization. We talked about all of that. So this next step, that's what's doing. In this case, it's setting the optimizer as Adam. I also am not sure, this type of objective function, what it is, but it's setting here as Adam, and the loss here, it's also using a type of loss function here, this sparse categorical cross entropy. I also am not I'm not sure what this is, but I think the main point here is they're setting their parameters here, those parameters that we talked about. And then for metrics, they have accuracy. I'm sure they have other types of metrics, but they set as accuracy here. Yeah, and I apologize. I think the intention was to, just see, like, connect the dots between what we saw as concepts and how, they're setting here. But I'm not like 100% sure why they're using these specific settings. So now after you set, you have your training data, it's normalized, you set, the number of hidden layers that you're gonna have, you set the parameters that you're gonna use, your optimizer, your loss function, which metrics you're gonna use to evaluate the model. Now we can start training the model. So yeah, we use this fit function method this is going to fit the model to the training data set. So we're just using here, our training images, we're giving the labels, which is that, 0 from 9. And it's assigning epochs equal 10. And we talked about epochs, right? It's how many times the data set is going to go forward and backward through the network. And then it takes a little time because each epoch, is running all of those 6,000 images, and it's already giving like the loss and the accuracy for each epoch of the training data set. So this is just for train, this is not for test. And what you can notice here that each time that the data set goes through the neural network, the loss, starts decreasing, right? You can notice that it's smaller, 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 and the accuracy increases, right? It goes increases, 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 and that's because what we saw, every time the data set is going through the model, the model is learning a little bit more, right? It's grabbing another important feature that it didn't capture before. It's learning more, so that's why your loss decreases and the accuracy increases. Does that make sense with what we talked before, from the previous days? Yes. Okay. Good. Yeah. Loss and accuracy metrics are displayed. So yeah, in the very end is about 91% accuracy for the training data. So now this is just for the training data, right? And we need to test for the test set as well to actually see if it's doing good or not. So that's what it's doing. It's getting the test, it's assigning test loss and test accuracy, and it's gonna assign values from that using this evaluate function, which is using our test images and our test labels. So we can see that the test accuracy was around 89%. It's less than training, which is expected, and it's not that bad, right? It's actually doing very similar values for accuracy. Yeah, and he makes an important point here. The gap means that it is overfitting. We talked about overfitting because the model gets too acquainted with the training data set. And I think it has some examples here. Yeah, this is another tutorial about demonstrating overfitting. And then now you can actually start making the prediction. So we trained our model, right? We evaluated. In this case, we said, okay, this is fine. I'm happy with 89% accuracy for the test data. So now we start making predictions, and the way it happens is it gives probabilities to each pixel of the image. And we talked about Softimax, right? This is an activation function. So the probability model is just grabbing our trained model and assigning the Softmax activation function. So now it's gonna predict our test images. And now we're gonna see the prediction for the first image from our test set, the label of it. This is just the arrays, okay? So it's just showing this is each pixel value of that image. And that's the confidence of each image. And the argmax, this is the maximum, the most confident of our image 0 is that boot that we saw before. So it's 9, which is a high score. And okay, task label, yeah, this is actually the label. So it is predicting the right label because it is the 9 label for the ankle boot. And then here it's plotting an image to see the full set of all the 10 classes that we have. So we're not gonna go through too in depth, but this is just defining a function to plot each image that we have and plot the value array as well. So let me see. So yeah, so this is just, this is the first image. It's predicting 100%. You can see here that, the value that is most confident is this label 9. And you can actually see a little bit of the 7. So this is just outputting the predictions from the model. This is for image number 0, which is the boot. This one is for 12, which I'm not sure what it is. It's the sneaker. So this one has actually 64% confidence to the sneaker class 7, because it's also thinking it's the class 5 and 8, which I'm not sure what those are, but should be similar, like shoes in the shoes class. And here you can see different images with their predictions. So yeah, the boot, we saw this pullover 100%. You can see for each image how much confident the model was, and also the bar graph for that confidence for each class. This is just how to put in the pixel size. These are, yeah, just the different predictions. And I was gonna plot that for one of the images. This one is for image number 2. Yeah, 0 is the boot, and which you call 1, and then 1 is the 2, which is the pullover. And yeah, it classifies as 2 because that's the one you thought is 0, 1, and then pullover is 2. So it's just the model making the prediction. So did that make more or less sense? This quick example predicting the labels of each image, like what we saw the previous days with activation function and hidden layers, the epochs, loss and accuracy. Or not so much. Yeah, there is a lot to learn from Java to CNN. Yes. And that's why I guess the goal of this this like 4-day training was to it's really just touching the surface, like really introducing just the the concepts, and what is what, the terms. And then once we get like the model like working well, like once we are happy with the model output, then we can actually dive into all of these like specifics and the coding and everything that is more complicated.
So I have a question, since this is quite complicated and new, and since you are going to run the model, and I mean we are going to work on that. Then once you say the model is kind of acceptable, or we have some results to show, will you be able to go through these same exercises with our own data for Cambodia?
Yeah.
So like repeat this kind of the steps, but with the data that we are actually using.
Yeah, right. I think that's the idea. Like once we have the model, then we can go, we can just give the cookbook, right? It would be something like a script like this, where we say like, okay, we chose this number because we know we tested this before and, it didn't work well, with another number. But we would give like the script, with the best accuracy, and then we can go through that and make sure everyone understands everything.
Okay, and I see a question from Carlos, which he's saying
How to use.
yeah.
So Carlos, I think you joined a little bit later, but one of the things that you can do, like after you train the model, and if you're happy with it, what happens is you can export that model, and then you can use that model, in Google Earth Engine, or another person can use that model. So you wouldn't have to go through, all of this again every time to use the model. Once the model, you're happy with the model, you can export that model to Google Storage or Google Cloud Platform, and then use that model, in different ways, different opportunities.
Okay.
You
Yeah.
can,
So what I see is like three roles on all these. One person that can be the developer, right?
mhm.
So some person that want to go deep on this and wants to develop their own models, right? Then other
Right.
person that understand and can make some sort of modifications to customize or to tailor the models for some specific results, and some others that maybe they don't understand, they don't want, they want only to consume the final result, that are the person that maybe will load it into Google Earth Engine or somehow, so we can read it in that way.
Yeah, you can have the model in Google Earth Engine. You can pull the model to Google Earth Engine and use there, and then you can plot your map there. The final output.
Yeah, and I think this idea is good because I think not everybody will need to know how to how to run the model or how to develop the model. But maybe some people, and as Ate mentioned yesterday, they are looking for people that can join them in Bangkok for like a longer internship where you would be working on this. So that's one possibility, that maybe one person or two people go and really work and kind of become experts. And then, but I think that the majority would be then in the second group. So people who are able to understand, follow, and kind of adjust the model. So that is our kind of like a primary target, I guess, for in terms of future capacity building. Which is why I was wondering, like, yeah, when do you think that we can start looking at this with the Cambodia data? When would be a good time to actually kind of dive in a little bit more?
Yeah, so like Karis was saying yesterday, I think once we do more of this research, and have the model refinement, and then like sharing this output with the Cambodia team, and thinking, assessing if it's good, then I think it's the good time to do the deep dive with maybe, yeah, select some selected people that will be more understand, I guess, and do that deep dive with the Cambodia data. And I think that's why, we know it's very complicated, and that's why we want to like make sure we have something that satisfies, is good, and everyone agrees, and then we can do the deep dive. Otherwise, I think it would be just too much, trying to do everything right now. Like if we were trying to get a good model, you know, doing these steps all together.
Okay, so how does that sound to the Cambodia team? Chaya, I mean, I'm asking you because Chaya or Nimol, because you guys are kind of like the primary kind of users or that you have in mind, but also anybody else that, yeah, like, what do you think? Does that sound like a good approach?
Hello?
Yeah, we can hear you.
Yeah, I think the plan is good. I think we should try and follow the step that the expert suggestion.
Yeah, and I'll just add, like, we can always go through these trainings and steps, like, as you know, many times as needed. We definitely want to make sure the capacity is built, and you have all the tools and, you know, knowledge necessary to run these models, and, you know, the sustainability plan, right? Keep doing that in the long term.
Okay, so sorry, Andrea, maybe you had something else to present, or we already started discussing about next steps?
Yeah, I guess I already started. That was it for me. And I apologize because, yeah, I wasn't really planning to go through the notebook, but, you know, I think that it was actually good. So I'm sorry if, you know, it kind of seemed clogged a little bit, but yeah, that was the end for me. For me, next steps would be the where we are now. And yeah, we talked, you know, Udom and Sapanya worked until last week on the data assessment, where we were just fixing some boundaries and make sure the data looks good. I haven't like cleaned that up yet. I need to do that. And then we're gonna outline a new data collection for them to, you know, maybe in the other pilot areas that was mentioned yesterday by Dr. Van Sang. We're gonna decide on that, and then, you know, I'll be working on with the team, with the SIG team, on researching and refining the model to make sure we get something that works, and then we will be presenting those outputs to the Cambodia team.
I have one question. That is the plan that we are discussion for the plan until the end of this year. It's only in it will be covered in pass 3, pass 2, pass 3, and pass 4, right?
Right. Yeah, we can discuss all the phases now. So I guess here in phase 3, maybe I do need to add, like, you know, the transfer learning here to the Cambodia team after we get a final, like, good map, good output,
Yeah.
and then, or we do the final accuracy assessment.
So it means that in pass 2 and pass 3 that are from now until the December, that will be combined also with the proposed activity that I test right yesterday, right? That both of you and Ate will be work together to be improve for the model and also the testing.
Right, that's right, yeah.
Okay. It after that, from the September, we will be start for the detailed work plan on the training step by step to the participant after Cambodia, right?
Right, yes. I mean, I need to add this here. Yes, that's correct.
During from now to September, you will be test only the improve the model and also update for the sample data inside only the pilot site that we are working last time, or you will be explore to get more data for the whole country, or will be extend for other sample?
Yeah, the idea is I think we have a Damas appointment working with us, so maybe getting additional data from the other pilot areas, but we are like the models we are running, those outputs are for the entire country, even though we don't have data for the entire country. But yeah, the plan is to get additional data from other areas of the country.
Okay, it makes sense because Carlos mentioned that this stuff is we need to be back up for some more people that working on this, and also some step is in advance that maybe in our the participant today they will be not can follow all the steps that you have to explain, but at least they have some background that what is the flow and what is the Python and what is the machine learning, we have the prediction and also the learn during this 3 day. Maybe we need to be to be identified for the detailed work plan for from now to until the end of the year relating to the improved data, and also the who will be involved for the part 2 and part 3, and who will be involved in the part 4, and then detail for the training that can be support for the alternative or sustainable capacity to the government participant, especially for, in the GDA stats, and also the mapping participant also. That is the what is our the idea, and also we come up for the today. And really want to the volunteer that can be work with I'm not sure that who can be go to the to the Bangkok and work more closely, and also intensive work with Ate during in this few months, that it could be have the one representative from GDA or other department also, or we can be consider Udam or Sopanya that they can continue this work, because like some of the government staff, they are very busy and cannot really have the action from there. And we can be discuss more with the head of the department how we can be used bring the potential candidate to be cut up for the from the beginning of the work, and then they have the they build their capacity from the sales staff, and then they can be handle this work until the end of the we have the good produce of the good map.
Yeah, I agree. Yeah, and I second what Maria said. Great suggestions. Yeah, I think we do need to start thinking about defining the teams for each step, and have more, I guess, detailed plans for each phase, and we can definitely work on that.
So I just want to add to what Sofira was saying. So the reason why we have Udom and Sopanya working is that we don't want to take too much time from the people working at GDA and MOE, because everybody was busy with the land cover mapping. Now maybe things are a little bit better, and I would really suggest that maybe we expand the team, so it's not only Udom and Sopanya, but maybe a few others also join. And this is something that we can discuss with Mr. Chivin and Mr. Wang Seng. That's one thing. So about the teams, and then the second, also the same for like the internship or going to Bangkok. I think yeah, let's maybe propose few candidates and discuss this with the leadership, and get that. So those are going to be our kind of main resource people. So the sooner they can start, I mean, after possible to travel. Sofon, so he's saying no for me. What does that mean? Does that mean you're not interested, or yeah? Can you please tell us? Or you are interested? Oh, I see. Oh, I see. You're all already volunteering, people. Well, we need to discuss with Shai if he wants to take all the work. But yeah, no. But definitely, we can discuss this and make a like a bigger team. But for the time being, I think working with Udom and Sopanya is good because we can keep things moving, right? And then as people have more time from the GDA or from MOE to join, yeah, we can have a bigger team. So does that sound okay, Sofira and others, like that kind of approach?
Yes, maybe from finish today we can be have the brief summary for the result after our training that we can be bring this idea to be discussed with the director Mr. Dr. Seng Bang and also Mr. Kivin relating to the attitude and also the work plan that we would like to be achieved in this few months. Until the end of this year and also propose some activity that we would be continue to the next year and also other collaboration between our supporting and stakeholder relating to this activity and also propose the work plan that is the concrete work plan that we can be bring and discussion with the government and then request for their support that they have the interesting and also they are peaceful that they support this work and then we can continue and then we can be have the complete for the work plan for achieve our the goal in the group mapping and also we can be have the concrete or of the work plan that is for the build up for the capacity of the government counterpart that not just when the finish and then they still cannot be handled on the work. At least there can be no 50% of the what we have been introduced and also the step that we have been workflow on the produce for the final map. That is for the sustainable development of the capacity building inside the country. We cannot be keep all the technical inside the international or national consultant and then when the project finish and then the government cannot be controlled for all the process like Dr. Seng Wang have asking the question yesterday how can be sustainable or with the support on the program or any software that can be maintained for the supporting their work. Uh, he mentioned that last project that he's have for the ecosystem mapping. I'm not sure that they have the buy for the license to be run and then when the project is finished uh, they don't have any static support and also the staff also cannot be found for the other tool or free tool that can be continue this work. If I'm right, Chaya can be correct me if you have any idea on this.
Uh, for the right project, we had to buy a software like Mapscape to process the image. Yes, it's from Swiss. Uh,
Yeah, this is what we discussed yesterday with Dr. Wang Seng as well. I think that's why we want to do everything on a free and open source software. And also we'll see if possible to do some of the processing within on servers and similar to the UMD servers, we can help with the servers, like you know, have the capacity in GDA and MOE to run as much as possible independently, but also everything should be open source, and it should not come at cost. So that's one thing that we are really mindful. And as we talked yesterday, I mean, I'm not so much interested in the model, because Andrea can develop a great model and Ate, and it's going to be a failure for my program, because my program is capacity building program, and we are not building capacity of Andrea or Ate. So I think we need to really make sure that we have the people that are working in GDA and MOE understand everything and are able to do this on their own. That's why we can repeat the trainings as many times as possible. And I'm not so concerned about the timeline. So let's take it step by step. If we need to repeat some training, we'll repeat it 5 times until I understand it, you know. So.
Yeah. And also Maya, relating to this, can we also think for the build for the hardware inside the GDA also, like for the confidential of the data and also national ownership, that they should be how their
Yeah, I think
their Google Cloud storage, and also the database that can be support for the next working that they can be run by themselves.
Yeah, I think that's a great idea. And I think that was part of the, I mean, that's part of the kind of like the agreement that we have with GDA. I'm not sure that they have there some funds for field work and some funds for like a computer equipment and all that. So definitely, yeah, the idea is that they will have the capacity to run things on their own. So yeah, I mean, but it's just this kind of approach takes time. So that's why, I mean, when we look at October, November, that's what I'm trying to say, that maybe it will be January, February, or I don't know, next year, because yeah, it will take maybe longer than if we have experts doing this, like people who already know it. So I mean, what I want to say is that everybody should be a little bit patient. Yeah.
Thank Maya.
Yeah, but one additional thing that I want to say is that we didn't discuss at all about the field data collection. So where does that fit in this timeline? And are we actually planning something around the field data collection, or will you know that after you run the model, Andrea?
Yeah, Maria, I was gonna say, I think after this, next run, we will have a better idea about field data collection. I'm a little hesitant to, like say, okay, we need to do right now, or I think after the next run, which, we shouldn't take, like the next month, we should know about that. We can discuss more.
Okay. And when do you think that you will have the, so does that mean that you will need like a 1 month to rerun the model? Because maybe it's a good idea to wait until you rerun the model and then have the discussion with Mr. Chivin, the directors, or should we, Sofira, or should we discuss this at the moment right now? Should we wait, I mean, for the new model, or should we discuss right now?
I think we can be discuss right now and then present for the new model also. Maybe Matu can be suggested because Matu inside also Kalok also inside and we can be discussed. And also I would like to be have the idea from the Professor Sultan also relating to the for the capacity building for the next shooter also that he have involved a lot with the preparing for the capacity building so that we can be also get some idea from him.
Yeah, thanks, Matthew. And I think we can also we can discuss with Mr. Sotan and I mean, yeah, let's maybe think about maybe developing a more detailed work plan with this timeline, and then more detailed work plan that we can discuss all of us, and then suggest it to Mr. Chivin and Dr. Van Sen. And I think Dr. Van Sen joined all the trainings until today, so I think he is already well aware. But maybe Mr. Chivin, we need to give him some update. Yeah. Okay, anything else to discuss in terms of next steps?
Yeah, none from my end. Maria, I think I can, start putting this more detailed plan into a document, and then I'll share that with you. Does that sound good?
Yeah, and maybe you can make like a Google document so that then everybody can. Yeah, because we have three main groups here. We have GDA, MOE, and FAO folks, and whoever can contribute from this group to that work plan would be very useful.
Yeah, for sure. I'll just draft it first, and then we can share, and everyone can collaborate. I think that's a great idea.
Okay, well, I think that's it for this intro training. I learned something. It's not much, it takes me a while to learn, but I think others maybe learned more.
Yeah, I hope you all learned something, at least the basic concepts. And again, we can do this more, as many times as needed. It's not a simple thing. These models are not easy. It's involves programming and all of that. So it is complicated, but we will slowly get there. I promise. Thank you everyone for joining all these 4 days.
Yeah, thank you everyone. And we'll keep in touch. So we'll send the document and we'll take it from there. And then Andrea, you will also be in touch with Udom and Sopanya about next steps, right?
Right. Yes.
Okay.
Thanks everyone.
Take care.